So tomorrow at 1:30, we've got a great panel together to look at mapping hazard and risk. And we've got a colleague from Icon Engineering, from Environmental Systems Research Institute, from Digital Globe, and then a very smart researcher from Colorado State University. So we're going to put forward to you guys that mapping hazard and risk is really fundamental to understanding risk. And without the maps that we all use on a regular basis, it doesn't matter where in the world you are or what the degree of the hazard is or the relative vulnerabilities of the communities that are at risk. You need those maps in order to be able to mitigate for those risks. Then you No, back to the previous one. So this process diagram illustrates, I hope, that it doesn't matter where we're mapping hazard and risk, that it's a very data-intensive process. In Africa, that creates serious challenges because quite often the data doesn't exist and we're utilizing remote sensing or having to go out on the ground and harvest information about vulnerabilities from the communities themselves. In the US, I really did, Reese. In the US, in contrast, we're quite spoiled in that the National Flood Insurance Program several decades ago set up the initiative whereby we needed to map, in the case of flood, our physical hazard, and that's represented typically as a 100-year floodplain. That's created a wonderful foundation for us to build on that information, and now we're really very sophisticated in that we have technologies and data banks that provide all the infrastructural vulnerabilities that enable us to generate risk maps. And we have federally supported tools that enable us to couple all that together. We've got researchers and technologists that have developed data models, methodologies that enable us to take existing information and quite easily use that in order to generate the maps from the models that we use so that we as users can generate the maps. The LiDAR that you saw on the previous slide can be used to update and improve our mapping so that we can see, in this case, the subtle influence that a very detailed DEM, digital elevation model, plays out when we project the flood inundation service onto that map. Jeff Brani from Esri tomorrow is going to tell you a story with Esri's story map. This is information that is canned, it's readily available to all of us so that, for example, we can write really effective grant proposals. He's also going to take us through some nice eye candy so that you can see how geospatial information can be used to map different hazards, not just floods. In this case, we've got wildfire. We've got spatial analysis so that we can model how we might effectively get out of a hazardous area quickly. And then we can take that information into the decision-making and planning domain so that we can take the physical information to a planning community so that, one, they can understand it, and two, utilize it more effectively. And so that you don't get stuck on just flood hazard, we're also going to look at earthquake hazard, and Jeff's got a nice example from the recent Nepal earthquake of fairly straightforward spatial analysis, but done in a way that it empowers folks on the ground to be able to, in this case, relocate communities to safer places. Merging of different hazards so that we get multi-hazards and can bring that into a risk assessment for riverine hazards, slope-related hazards, and then possibly also earthquake hazards. The colleague from Digital Globe is going to look at remote sensing and how important the synoptic information that cutting-edge companies such as Digital Globe are, both during and after an event, not just because of the spatial detail that we can get from some of the new information, but also because of the temporal information and the ability to track the event. Olga spoke to the idea that we're not really quite as smart as we are. So in the case of the Colorado floods, it wasn't really the 100-year floodplain that was most useful to people. We also needed to be taking into account the fact that lots of material washed down off the hill slopes and created a flood regime that actually enabled the channels to change direction and location. So we need to contemplate how we're going to use new data, new technologies to map that. From a watershed planning perspective, in the fluvial domain, we need to understand how the rivers are responding to the great damage that was done to them as they rebound into some sort of equilibrium into the future. And Joel Schultz from CSU is going to look at various mapping and modeling technologies that enable us to look at the physical process dynamics of the fluvial system and how we can anticipate how to create a more stable and resilient channel moving forward and reduce the risk to communities that may develop alongside those rivers into the future. We might try and convince you that we need to move away from mapping hard lines and actually consider fuzzy boundaries as we consider the uncertainty related to mapping flooding, inundation, and earthquake intensities and other things that don't quite often play out in a straight line agenda, if you like. And then again, along the lines of watershed planning, utilizing technologies to both map and model other hazards such as wildfire, but then how that then influences the response of big rainfall runoff events that we saw in 2013. And then finally, and very dear to my heart, is the utilization of mapping tools and technologies to engage stakeholders. One, to glean information that we don't necessarily able to get from our models, and secondly, to enable those communities to better understand what those hazards are about and how they can utilize the data products to create a more resilient community themselves. So come visit at 1:30 tomorrow, please.
Thank you, Graeme. I take full responsibility for that as the technical